Again, good morning and welcome to Astronomy 100. We had a problem. We were in the middle of the session. The internet stopped on the computer. I was trying to go and get my laptop and then it came back. So anyway, I'm going to repeat everything that I said. The thing with it is you should have received a message from me today concerning the review for the exam. For those who did not do it, it is really a must that you have to do it for two reasons. The first reason is that the assignment itself, namely the review itself, is mandatory and it's a graded assignment. So you really do not have a choice in it. I mean, if you choose not to do it, it's fine. You're going to get a mark of 0. So that's really the only problem. But you really want to do it because of the fact that regardless of what you score in it, you're going to get full credit for it if you do it. That is really the purpose of this thing. I mean, the idea behind it is that to help you prepare for the exam. So that is the whole plan for the review. So do take advantage of it because of the two reasons. First of all, it's a graded assignment, you'll get credit for it. And second, because it helps you prepare for the exam. And the exams, as you can see from the syllabus, are extremely heavily weighted. So you really want to take advantage of that. The review will expire or will not be available by the end of the day tomorrow. So if you did not take it, and a lot of you did not do it, today is the day, tomorrow, and that's it. If you did already take the review, please, you have the opportunity to look at it again. You will not be penalized if you take it again. As a matter of fact, your credit will remain the same. So just take it as many times as you want, just to make sure that you're ready for the exam. So this is really the whole point in here. Thursday morning is when the actual exam is going to be available for you guys. So plan on working on the exam by Thursday, by taking the actual midterm Thursday. This is good planning. This is smart planning. This is smart learning technique. You really would want to do this whenever an assignment is given to you in any class, regardless of the class that you're taking. You really plan to do that the first time you open it. Then you know what you're dealing with it. Obviously, for this midterm, once you open it, you have to submit it because it's only one attempt. But in general, whenever you're given an assignment in any class, start working on it as soon as it's available. This is really good learning technique. Now, if in case you cannot make it on Thursday, second plan and a lot less effective way of doing things in any learning environment is to do it the next day, which is Friday. Now, because those 2 days are working days, there may be a leeway for this environment we're working online, where we probably can postpone this until Saturday. Saturday, those 3 days are the ideal days to take the midterm. Now, if you leave it to Sunday, you really are delaying things. You don't want to do this on Sunday. Sunday is really basically when you're constrained from all kinds of things. Allocate the time on it, do it on Sunday, knowing that this is probably the last time you do an assignment like this one, leave it to that day. The exam is actually due on Monday. Under any circumstance, planning for Monday is a terrible plan. It is not a good plan at all, okay? You have that opportunity if in case all kinds of things work against you. I mean, you have many things that don't work well for those 4 days, which is kind of very hard to have all of those things not work. But if in case everything is disastrous, and now you have Monday. Monday is playing with fire. Monday is really dangerous day to do this, but you still have it on the day. But believe me, that's the day when all kinds of things can go wrong, and they will. Namely, the problems with the internet, problems like what happened today, this morning in here before this session, problems with the power, problems with the I don't know, the boss really wants you on that day, problems with family, health issues, all kinds of emergencies, they happen on that day. So do not plan for Monday at all under any circumstance. You still have that day, but do not plan for it. It's terrible planning to do it on Monday. Okay, so this is the idea that I wanted to have it across. So the point of the discussion, the first point of the discussion today is do the review before it is due. Okay, the first do is GO, the second do is GUE. So do review as soon as possible. Okay, so this is the first point that I want to make sure that you guys are on board with me on it. And we are all on the same page, because it's a free grade, basically, for all practical purposes. Take advantage of it, prepare your exam, and be ready by Thursday. First point makes sense? Sounds good? Okay. I'm going to share the screen to see what we have at stakes this week. Hopefully the internet is working, because I'm not getting any replies back. Excuse me. Share. Can one of you confirm via the chat that you're looking at the screen that says week 6 and week 7? Yes, no? Or maybe? Okay, very good. Thank you. Very good. Okay, so we're looking at basically at what we have in content. Again, as I was saying, this is the review where it is. It's from last week, actually. And it's due September 29th, which is tomorrow evening at the end of the day, basically 11 p.m. It's going to close, and you will not have a chance to look at it again. The actual midterm is due Monday, October 4th. However, it is going to be available Thursday morning, okay? Thursday, I already sent a message yesterday morning around 7:30 in the morning to everybody that I would be on campus. So the day when the midterm is going to be available for you guys, I will be on campus very early on in the morning until probably noon or so, okay? If you choose to meet in person, because I will be in the office at that time, please send me a message by noon tomorrow. So I really need to know, I already explained that in the message that I sent yesterday. Please send me a message, let me know that you want to meet in person and that you're coming, and so that we can plan for it. Again, because there is a very limited time, I mean, and I have so many sections just for this class alone, let alone the other classes. So if you want to, we can meet on that day. So that's when the exam is going to be available, and it extends till Monday, October 4th, okay? So this is the things that we have. This week, we have Unit 39. Unit 39 is not part of the midterm, at least this midterm. So when you open the midterm, you will not see anything related to Unit 39. You will see things related to Unit 38 and before, but not Unit 39. So this is not included in this midterm. It's going to be included in the next midterm, so it's not something that we have to skip altogether. So it's something important, but not now, okay? So that we are on the same page. The discussion again, we already raised one point of the discussion. That's where it's going to go after we basically do the recording and post it in here. And that way, we're going to have the recording in here and the discussion item in here. The previous week items, or at least some of the points that were raised in the previous week, are actually reviewed in here. And this is the objective for this week. You guys are familiar with the format. There is something that I would want to dedicate some time to today, and that is the project that we have in here. I'm not going to go through it thoroughly. I'm going to introduce it. Down the road, after we're done with the exam, or at least in the middle of the end of the exam, we're going to come back to this point in here, and we're going to talk about it in more detail so that you guys know exactly what you're supposed to be doing, okay? So there will be no confusion about what is in there. But today I'm going to just introduce it, okay? So let's go through the objective. for this week. As you can clearly see, the first item in here deals with exactly what I was talking about, namely the review, the actual midterm, and when it's due and when it's available, and all of the things that we've been talking about up to this point today. So this is the first item. The second one is, of course, the topic of the week, and the topic of the week is Unit 39. So what in the world is Unit 39? From the picture you can tell it has to do with the moon. The moon happens to be, at least the Earth's moon, which is usually written with a capital M, just to make sure that there is only one. So the moon of the Earth is an exception in itself, and it helps us understand a little bit more about the solar system, about its history, about basically what it went through, and it's about its structure, current basically structure. The moon is actually a great item to start with, outside of the Earth, of course. When we explored it in the previous units, and we saw the Earth can teach us a lot about the inner planets and also the outer planets. The moon is actually the nearest object to Earth that is of a great interest for the same reasons. Well, the moon, for one thing, for the Earth, is an exception to the rule. Earth, when it comes to moons, has a big one. Not only that, but it's an inner planet. Inner planets normally do not have moons. If you look, for example, to Mercury, it does not have a moon. If you look to Venus, it does not have a moon. If you look to Mars, it has a couple of small rocks, a few kilometers left and right, but they are not actually moons. They're captured asteroids. So that's basically, so it's an exception. We can understand that. So because of that, I mean, when you look at the outer planets, they have a lot of moons, big and small, bigger than this moon and smaller than this moon. So they have a variety of moons. But for the inner planets, this is something that is an exception to it. In terms of density, the moon's density is 3.3 grams per cubic centimeter, versus the Earth, which is 5.5 grams per cubic centimeters. And the Earth is the most dense planet in the solar system. The thing with this number is, it means that it must have formed in the same region where the Earth has formed, because it has similar density. It is not an object that formed, for example, in the region of Jupiter and then migrated toward the region where the Earth is, and all of a sudden it was captured by Earth. This is not possible just because of the density, number one. Number two, the density is different than that of the Earth by a big number. I mean, 3.3 and 5.5 are a big difference in terms of densities. That means that the composition is different, especially in terms of the iron composition. The iron is really what weighs the density higher. So it seems like this object is poor in terms of iron versus the Earth. Okay, so that is something that we need to understand. So where did the moon come from? That's really the first question that we wanted to understand. Where did we get it from? How did the Earth get this moon? Because it's something that we must explain. There were some theories basically trying to explain the moon, and they basically boil down into two. The first one, or at least three probably, okay? The first one basically is that the moon could have been a planet that formed, because it's a big size, okay? It's bigger than Pluto, by the way. A planet that somehow was orbiting the sun in the same region as the Earth was, but for some reason it was captured by the Earth. There is a problem with this approach in terms of the region. Why it does not have the same constitution as the Earth, for example, in terms of iron densities and things like that. So that is a little bit odd. The other thing also in terms of its composition, it seems like it has similar composition for some of the elements than the Earth. So it must have at some point was in contact with the Earth. Okay, so this is not good. How about the fact that maybe it was part of the Earth, and then for some reason, when the Earth was spinning super fast, part of the Earth, basically the crust of the Earth was ejected, and that formed the moon. Well, then it has other elements that the Earth does not have. So that seems to be not good either. Okay. The other thing also is that it could have been formed in the same time as the Earth was formed from the same planetary disk, and that one actually, and at the end it was captured. It stayed basically where it was. So it never really left it. So there is all kinds of theories, and they really don't fit a lot of the models. The best model, really, the leading theory, the emerging theory, is a Mars-sized planet that formed. So it's really a kind of hybrid between those theories. Mars-sized planet that was basically in the same region, probably the same orbit as the Earth was. Same orbit, following one another, okay? But because of a gravity, they were too close from one another, they get into a collision with one another. That can explain a lot of things. It can explain the composition, which is slightly different because of the fact that they formed slightly differently. And then the fact that the collision, part of the elements that were in the original planet, they actually went into the Earth. And now the composition has a lot of similarities, and actually they share common elements because at some point they were in contact with one another. And then things that did not really initially were needed, they started to emerge as really a consequence of that. One of them is the inner core of the Earth that seems to have some asymmetry, not symmetrical. If it was really the original constitution, it should really be uniformly distributed, but there is an asymmetry that seems to be a remnant of that collision. That's one thing. The other thing also, and we're going to see that toward the end of this unit, is the way the moon moves around the Earth. Here is the idea. All the planets, for the most part, are on the same plane, basically like a pizza, like a pizza when you flatten it, and in the center is where the sun, and all of the planets are supposed to be on the same plane. So this is the ecliptic. This is the plane where everybody's supposed to be. Obviously, the Earth is slightly tilted. So this is the equator of the Earth. This is the ecliptic, and they make an angle of 23 degrees. In other words, the North Pole of the Earth is this way, because the North Pole and the equator are perpendicular to one another. So there is one thing. The moon is not going around the equator of the Earth and is not going on the ecliptic. It's making an angle that tilts between 18 degrees and 29 degrees, okay? It's making an angle that is fluctuating left and right. And for numerical simulations, when computers are put to the test and they put this Mars-sized object and they let it hit the Earth at that specific angle, it gives you this kind of inclination. It gives you this thing. So again, this idea was proposed a long time ago, and now it's emerging to explain other things. So again, this is a mark of a good theory, that it explains the previous things and predicts models to explain something that we didn't see before, and now we're seeing in the matter. So this is really where where we stand right now in terms of the origins of the moon. Okay, so this is where the moon must have come from. In terms of its appearance, the way it looks like when you look at it, the moon is tidally locked, again for the same reason, because of its proximity from the Earth and because of the force of gravity. It's tidally locked. What that means? That means that every time it spins around its own axis and goes around the Earth, it's the same period, the same time it takes for it to go once around the Earth, which is 30 days roughly, lunar month. Also, it takes 30 days to spin around its axis, which causes it to basically have only one face facing the Earth all the time, because as it's moving, it's spinning at the same time. So it's always have this face facing the Earth. This is what we see. This is the side that we see on a day-to-day basis, every night. The other side, the side that we can never see, is similar in look, although the distribution of these dark regions on it is slightly different versus the bright regions on the moon. So what are these dark regions? They are lowlands, relatively speaking, compared to these highlands. Highlands are higher, they're lit more, and not only that, but their chemical composition is different. This is basically rock and aluminum and some minerals, and this one is mainly basaltic rock, okay? So this seems like the origins of this part in here is some sort of a lava flow in the past. That's one thing. How do we know that? If we look at the age, when we basically did radiometric, basically using radioactivity to date this rocks versus this ones, there is a difference in age. The rocks on this side are older than the rocks in here in the lava. Why? Because again, you had some sort of a surface activity. So the moon in the past must have been geologically active. That's one thing. The other thing also, if we count the number or the density of the craters, and there are a lot of impact craters from the asteroids that must hit it and the early bombardment, basically, of the solar system. So this is telling us a lot about the solar system. They're far more dense, meaning the spaces between them are smaller in this region than in this region. So it seems like whatever geology that happened, it happened after this, or at least during this period of heavy bombardment. Okay, so this ones in here did not have geology, so there was no cover-up, if you wish, of the evidence, whereas this one, there was some cover-up of the evidence in this region, indicating that this region was more active in terms of that. So this is really the main difference between the two. These bright regions, which are called highlands, and this points in here, all of these craters there, of course, the craters in here, some of them are of volcanic origin, because you can clearly see these things are called rays, indicating the flow of lava in the past of the moon. So this is basically the main thing that you can see on the surface of the moon. It's telling us a lot about its history, telling us about its geology. The moon right now is basically geologically dead for all practical purposes. It's not doing a lot. So if you look at the structure, how do we know the structure of the moon? How do we know any structure for that matter? First of all, either we model it through something or we actually go and test it. One of the ways to test inner structure, is to look for quakes. And moon has moonquakes. They're mainly due to the heating that is caused by this tidal lock, if you wish. Every night here on Earth, every day, actually 24 hours, the Earth goes through 2 tides, okay? High tides and low tides, 2 of them each, okay? And that is because of again, the moon is pulling on one side of the Earth and the Earth is receding from the other side, so we have the tides. The same thing, because Earth has the ocean, so it's easy for it to do that. It's actually not easy. It's also causing kind of energy losses also due to the motion, which means that the Earth is slowing down and is spinning. The same thing is actually happening to the moon too, but it's happening on the entire surface of the moon, the entire crust of it. So it's like you take, for example, dough and you start to work it. As you work it, of course, internally, there will be energy due to this motion, and that energy is the energy that is causing quakes, because there is motion of the inside of the moon, okay? The heating. So those quakes reveal an internal structure of the moon. It seems like the moon also have a crust, at least the model that we have in here based on the data that we have collected. It has a big mantle and it has a small core that has an upper core that is an outer core that is actually liquid, but it's mainly made, unlike the one of Earth, which is really iron. This one is some sort of an iron silicate, basically a combination of silicium and iron. And then you have the iron core itself, which is the solid part of it, which is made of basically iron and nickel. So this is, again, the internal structure of the moon and how we came to know it. So we know about its outer layer, we know about the inside. Most of the moon is covered with dust, and the dust is the remnant of those impact craters, the impact that hit the moon, and the impact, they come with different shapes and forms. For the most part, you have those circular shapes. Sometimes you have a bulge inside, and that is basically the impact too strong at a given angle in such a way that yes, it creates an indentation, if you wish, in the moon, but then the energy will cause the part of the inside to come out. So again, this is the structure of the moon. Again, the moon was of a big interest to us in the past, and it's, to some extent, it fell a little bit out of favor in terms of comparison to Mars. but it is still a heavily studied object. It tells us a lot about the solar system, especially this impact in here. If you look at the different surface, for example, Mercury or Ganymede or Callisto, and you see also similar composition in there, you can tell how active that object was and when did it lose its activity. Okay? Versus, for example, the surface of the Earth or that of Venus, for example, which is reworked because they still have an ongoing geology that is basically reshaping the entire surface, hiding, if you wish, the evidence of that early bombardment. So the moon is a good model to study the rest of the solar system. And it still actually has some interest, at least in terms of science and even some in terms of commercial interest. So it's still an ongoing topic, and there are plans probably we're going to go back to it, whether manned or unmanned missions. So this is the thing that I think the Artemis mission from NASA is the one that is planned to be in the near future to go back to the moon. So again, moon does not have an atmosphere. And that's basically the whole point in here for this unit, okay? So let me go back home. And so we covered the topic in here. I made a big fuss over this midterm. Hopefully you guys are going to take seriously. And then we have this project. Again, we're not going to start the project right now. I'm just going to give you an overview of what the project looked like, if you wish, an introduction to it, okay? I'm going to open it and see what's going to happen. It says that it's due October 23rd. So I'm going to click on it. As a student, of course, I'm looking at it. And it says this assignment is locked until October 4th at 8 a.m. That means I cannot see the content of this until that day. What I can see right now is the rubric, how it's going to be graded. It's out of 61 points. Okay. This is a good thing to look at when you're doing assignments like this one, is to look at the rubric. At this point, it doesn't make much sense to look at it. But the point being in here is that when you're doing your assignment on this project, please pull the rubric next to you, put it next to you, look at it extensively, because here is the deal. It's saying I can earn 5 points if I do this. If for some reason I don't do this and just do this, then I am going to have 3 points. If I don't do neither of those two, I'm going to have 0 points when it comes to this point in here. Then it's telling me I can have 1 point, 2 points if I do this, or no points if I don't do that. Okay, so it's telling me how it's going to be graded. And it's a good idea to have in mind basically this rubric when you're doing your project, okay? So it's a good idea while you're doing your project to have the rubric in here. Obviously, right now, I can do the project because I don't see it. I don't know what it is. So we're going to go a little bit, because one of you guys sent me a message over the weekend about the idea of retrograde motion of Mars and things like that. And because it's an item of test, it's not a bad idea to see what we're talking about. So at this point, it is not the full project that I'm going to look at. I'm just going to go over an overview so that we have an understanding of what's at stake in here. And then later on, we're going to hammer it in detail so you will be at ease with every single question in the rubric, because you can clearly see there are too many of them. There are a lot of things that needs to be done, which means that the minute it's open, we really have to start on it. I know it says October 23rd is when this is due, but we really have to get going on it as soon as possible. Okay, so let me leave the student view to see it in full thing in here. Okay, here is the actual product. Again, this is just an introduction to it. This is not the whole thing. You will see 2 links in the instructions. One of them is a may. You don't have to. You may. It's an option. You may submit your report using this form. That means you may choose not to do it. but submitted in a different fashion. However, whatever you do, you need to take advantage. You must do all of this in order to get the entire credit for it. If you do this PDF file, it's going to help you take care of all of this. If for some reason the PDF file does not work for you, or you don't like it, or it's not properly aligned the way that you like to organize your work, or for some reason it does not save, you cannot open it, or whatever reason there is, remember, this is not a requirement. This is an optional thing to do, namely this link. Okay, so I'm going to skip that link, but I go to this one. That's where the whole thing is, actually. That's where the instructions of the project is. I'm going to click on it, and it has a lot of reading, so I must read all of this in order to understand what's going on. Okay, so let me see what's going on. Just like I said, some questions in here: question 9, question 8, question 7, question 6 and 5 and 4 and 1 and 2 and 3. So there are a bunch of questions that I really need to answer. Okay, but at this point, I'm going to just go and edit in here, trying to understand what's going on, so that we know historically Mars has exhibited a weird behavior that humans, or at least the early basically observers of the sky, were puzzled with it. Mars, like everybody else, rises from the east and sets in the west. Except sometimes in the year, as it's rising, it's moving like in the same direction as everybody else, it moves backward and then starts to move forward again. That backward motion is what we're interested in, the retrograde motion of Mars. Okay? It turns out not only Mars that does that, everybody else does it too. All the planets do that. Actually, I listed in here some few of them. Mercury, Venus also do it. Venus actually is also the next one that is obviously does the retrograde too. And then Mars, of course, that's the whole thing, how we started with this whole thinking. And then we have Jupiter and Saturn. Those are the planets listed in here. And we have a dwarf planet actually that exists in the asteroid belt in your series. And that's between Mars and Jupiter. And that also exhibits that behavior if we keep track of it. So all of these objects seem to do that, okay? What they're giving us in this table in here, quick look at it, is that how long the year on those planets are, or those objects are, because Ceres is not a planet. Well, a year on the Earth is 12 months. The year on Mercury is slightly less than 3 months, 2.89 months. The year on Venus is 7.38 months. The year on Ceres is almost 6 years on Earth, 55.2 years. Okay, no, 5 years? 5 years, 5 years, almost 5 years. I'm sorry, almost 5 years. Okay, Jupiter is 142, more than 12 years, and so on and so forth. Number 4, Saturn is ridiculous. How many months? For Saturn to go once around the sun, the Earth goes 356 months. Okay, imagine how many years that is. Do the math. Okay. Okay. So that's the table is giving me this. It's giving me the last occurrence, at least according to the data that is reported in this table of when the retrograde happened. So on this one, on February 26, 2020, there was a retrograde motion for Mercury. On September 13th, 2020, there was one actually for Jupiter, and so on and so forth. The point in here is you're supposed to find when the next occurrence you're going to have. So you're going to do math in here and tell me when is it going to happen the next time around. We're going to go more about this math in here and how it goes, okay? So you're going to calculate S, puts in here, put it in here, and then as you find it, you're going to make the corrections in here. Okay, so let's understand now the 2 points of the retrograde. Let's understand what's going on. Of course, before the modern theory, which is the more accurate theory, where the sun is the center of the solar system, people believe that the Earth is the center of the solar system. So this model is called the Geocentric Model. Because Mars, we believe it initially that everybody is moving on a big sphere around the Earth, but because Mars moves backward in the sky, so we contrived this model where we say actually Mars is going on a circle, this circle, around the circle where it's going around the Earth. Okay. For example, in position 2, this is the circle. It's centered in here. In position 1, there is another circle that is probably centered in here. Position 3, there is another circle that is probably centered in here, and you can draw a circle in here. So there is a bunch of circles in here. We're drawing only one of them. So on last time when it was in position 1, I can take, when I'm looking at Mars, I think Mars looks like this straight out line. From the Earth to Mars, I draw a line from here to here, and I project it. It's going to be somewhere in here on the screen. Okay. And then later on, it's going to be projection from here, from the Earth to 2. It's going to be somewhere in here. Earth to 3 is going to be projection in here. Earth to 4 is going to be projection to here. Earth to 5 is going to be backward. So that is when the retrograde motion happened. So according to geocentric model, I can understand the retrograde. I can see that in position 5, the Earth, Mars appears to be moved backward in the sky, because every time it's moving this way, and then it appears to move backward in versus the stars in the night sky. Position 6 going to be backward also still. Position 7 is going to be backward. So remember, in position 4, it was somewhere in here, and then 5, 6, and 7. Position 8, it looks like it started to move back in the same direction as it was moving in the earlier. Position 9 is going to be back in here. Position 10 is clearly outside, and position 11 looks like it has moved forward. So if I draw the lines in here, I draw 1 in here, 2 here, 3 here, 4 here, 5 here, 6 here, 7 here, and then 8 here, 9 here, and 10 here somewhere. 11 in here probably. Okay, so the point being in here is that I can understand based on the geocentric model how retrograde motion happened. I can take the same thing. By the way, this stuff is also part of exam 1, okay, part of the midterm, because this is one of the few chapters that we saw in the beginning. In the heliocentric model, both of them, Earth and Mars, spin around the sun. However, Earth, because of its proximity to the sun, moves faster than Mars does. This is the same period. The Earth covers a bigger arc than Mars does, because Mars is moving slowly. Remember from the table I showed you, the year on Mars is 22.6 months. So it's almost 2 years for the 12 months on Earth. So its move is extremely slow compared to Earth. I'm here still on Earth. I'm looking at Mars on this position, from position 1 to position 1. So I'm going to draw a line from 1, cross it to 1, and see where it's going to land. It's going to land somewhere in here. So this is how it looks like versus the background night sky. If I take it from position 2 and look at it, it's going to move forward. So position was here, 2 was here. So it has moved forward. Position 3 and position 3, it has moved forward. Position 4, it has moved forward. Position 5, it appears to have moved backward because the Earth is overtaking Mars. So it appears to have moved in the background. Position 6, it moves even back in the position. Position 7 is probably going to move forward. Position 8 move forward. Position 9 move forward. So again, it looks like it's similar to the first one too. So both of them can explain the retrograde model, motion of Mars. Whether I'm looking at the heliocentric model or the geocentric model, either one of them can explain that to me. However, one of them not only explain the retrograde motion of Mars, but they explain also other retrograde motions, namely of Venus and all of the other objects, okay, but also can predict other things in the future, what might happen. This is the predictions. Remember, a theory is not just to explain what happened in the past, but it must explain what's going to happen in the future too. So this is something that you're actually going to predict when it's going to happen next time around, based on these calculations. So a quick warning on this S in here. S, you're trying to find the synchronous, basically, time. So you have it now, so you're going to have the multiples next time when it's going to happen. So that's basically in a nutshell what this S is. What this TE stands for is 12. T is the period, E stands for Earth. So the period of Earth is 12. So I could take this TE and put 12 in here and in here. This number never changes 12. This T depends on which object I'm looking at. For Venus, for Mercury, This is 2.89 and this is 2.89. For Venus, this is 7.38, this is 7.38. For Mars, this is 22.6 and this is 22.6. Remember, this number changes, it never changes, it's always 12. And then I put the values in here and I do the calculations in here. I promise we'll come back to this one in more detail. But the point in here for this bars, what do they mean? If you took algebra, you know exactly what these bars mean. If you did not, what they really mean is ignore the sign, because this number, when you calculate it, it could end up on your calculator positive or negative. Do not write positive or negative. Okay? Just write it as a number. So if the answer is positive 2.7, for example, just write 2.7. If the answer is negative 2.7, just write 2.7. So that's what the bars means in here. The bars are called the absolute value. So just take the absolute value, okay? Ignore whatever comes in between them in terms of signs, okay? Because calculators are smart enough. If you tell it 3 minus 1, it tells you it's 2. But if you tell it 1 minus 3, it tells you it's negative 2. For our purpose, we don't care about the negative or positive. We just care about the absolute value. We care only about the number, okay? 2 in this case, okay? So that's the whole idea with this symbol in here, which we call the absolute value. Again, this is just an overview of a project. If I look at it from the vantage points of a student and go back home and try to look at it now, it's going to tell me this project is locked, okay? So I'm just trying to show you in a nutshell what it is, okay? I know one of you came in late. There was a discussion item. It's actually in the chat, okay? So I'm going to stop the share screen. And the item that we made a big fuss over was the fact that you guys have to do the review. And that is the item of the discussion today, is do the review as soon as possible, okay? And we went through the content for this unit. And we also went through at least an introduction, an overview, if you wish, of the actual project. This is one of 3 projects that you're going to be receiving. This project, and there is another project that I'm going to post, will be concurrent. And those projects, you choose one or the other. Okay, you don't have to do both of them. So if you don't like this project and you like another one which has to do with stellarium, you do the stellarium. Okay, so that's the only option. But the third project that has to do with the observation of the moon, that is actually not an optional. That is actually a required observation that you actually physically have to go outside and do. Okay, so that is when it comes to the project, and you have to submit them. How about now, Christian? Okay, very good. So again, I know there was an issue early on when we started the class, so I'm going to make sure that I don't include that part in the actual video today. So the video may take a little bit of time to be uploaded to make sure that there is no private information that is posted in it. And that's the only thing that's probably going to delay it today, but hopefully you will see it later on and take care of things. I'm going to stop the recording. Unless you guys have a question right now. Can benefit everybody else. No, so we're going to stop it. Oh, yeah, I don't know if it's part of the recording or not. I don't think I mentioned it, the fact that on Thursday I'm going to be on campus. So if you guys want to, I already sent a message, so please watch the message or read the message that they sent yesterday at 7:30 in the morning concerning a potential one-on-one meeting this Thursday. If I did mention it, it's because probably it was that disruption that threw me completely off. Okay, anyway, I'll see you guys next time. So let me stop the recording.